Welcome to the Data Future channel. This is Shekhar and I am a data scientist. So in this particular session, we are going to develop a machine learning model where we can predict the fetal health based on the different the parameters which are taken from the different tests which are conducted on the pregnant mother, okay, or the woman, we can say. So here we have used the four different models, machine learning models, to predict where the health status of the fetal, right, whether it is normal, whether it is suspect or pathological. Okay, so let's get started. Here, the main intention is we can just predict the health, fetal health, so that we can we can prevent the child or maternal mortality, right? And for that, we have used basically a logistic regression classifier, then KNN, k-nearest labor, random forest, and these gradient boosting classifier. These popular classifiers we have used, right? The first step is we are importing a required libraries here. So like NumPy, Pandas, Matplotlib, Seaborn, these libraries. These are the algorithms we are basically importing here, and some of the metrics we required, some modules for the training the data, some modules for the cross validation, some modules for the feature scaling we are using. So step by step we will see all these things. Okay, so I will be running this also. Okay, next one is we have to load the data. So my data is there in the file, in the CSV file is the fetal health. So if you can check this data, so this data is having around 22 columns, means you can see that the baseline value is there, acceleration, fetal movement, uterine contraction. So these are the medical terms which are used, and these 22 the attributes are there. Out of that, 21 attributes which are related to the test which are conducted, and from that we are getting these values, right? And all data is, you can see, that is the numerical one. So how to check? We can see that in the exploratory data analysis. And finally, our target variable is fetal health, where we there are three categories. One is normal, suspect, or pathological. So 1, 2, and 3, like this, right? So we'll check what is the size of the data. It's a 2126 records are there and 22 columns. We can list down these number of columns here, so you can see these all the test, these parameters coming from the test. Okay, and based on these parameters we can predict what is what is the condition of the fetal, right? So when you use the dot describe function to the data, so it will give the count, mean, standard deviation, minimum value, 25th percentile, 50th percentile, 75th percentile, and ma- maximum value for all these attributes, right? So yes, now you can check the whole information about the data. Here the column names and its data type. So you can see that everything is in the float data type and all are the non-null values. So there is no any missing values present in the data, right? So this already we have checked. Now you can check for the missing values. There is a no missing values is present in the data set, right? So this is good. Now in this case we are having a three categories, means it's a multi-class classification, we can say. So here the normal, suspect, and the pathological. So if you predict the fetal health, then you can diagnose it, and you can take a corrective actions, or the um, you can take the treatment so that you can reduce the mortality. Right. So our target variable is the fetal health, and you can see that basically 1 2 3 is there. So if you can check here the value count of the fetal health, you can see that most are the normal one, second one is the suspect, and third one is the pathological. So this data is quite imbalanced, we can say. So if you can check in terms of the bar chart, you can see these counts here. The majority class is one, actually normal one, and rest of two are minority class, we can say. Okay, this is the bar chart with which we can see this distribution of the data. So you can plot it on the graph pie chart also. Here you can see 78% records are in the normal class, 8% is pathological, and 14 in suspect. So the data is quite imbalanced, because imbalance in the classes. Okay, no issues. We'll check how we get the accuracy based on this, right? So we are checking the distribution of the data um, in each column or the each attribute. So you can run this and you can check. So the data is quite the skewed for some of the columns, and some of the columns it is nearly normally distributed, but not exactly normally distributed, right? So from the histogram we'll get the what the actual distribution of the data. Now next one is the correlation matrix you can do. So for the correlation matrix, so what you have to use the numerical data dot cor. So everything is numerical, and from that you will get the correlation among this data. So you can check how your data is correlated to each other. So you can check the um, uh, you can check how these variables are correlated to the final variable target variable, as well as how these are correlated with each other, right? So this is the matrix, but everything is number, so you can't understand this. So for that, what we'll do, so first we'll check the correlation with respect to the target variable. So here you can see that by using this correlation matrix, and by using a heat map you can plot this, right? So one more method is there with which you can plot this correlation, and you can see that these values are in light blue color is highly correlated with the final the target variable, right? So and rest of all are not that much correlated with this target, right? So if you want to check the value of the correlation, so you can see that here the most correlated values are this 48%, 47%, 42%. These three variables are, or the parameters are highly correlated with the fatal error, but not that much. It's a less than a 50% itself, right? So yes, so we have to check how these values, these columns are correlated with each other. And for that, I am plotting here the scatter plot. And in this scatter plot, you can check if they are highly correlated. You can see there is a positive correlation, negative correlation in some of the columns. But in on the heat map, you can see it. Here I have plotted this scatter plot here, and by using a heat map you can see the values. Now you can see that this dark blue, the color is highly correlated, right? So you can see that these values, the histogram mode and the histogram mean, are highly correlated with each other. Okay, nearer to the values, you can check that also, right? Here these values are also correlated, baseline values and this thing. Okay, so next thing is, yes, we have to pre-process the data. We have checked the data visualization here, and we got all the columns are numerical one. So no need to worry about the feature engineering to like label encoding and the one hot encoding. But here the data, if you can see the data, so data is having a different scales actually. So for that we have to scale the data, and for that we are having the two techniques. One is the normalization and second one is the standardization. So these are the columns we have used here, and we have just use the standard scaler actually. So what it will do, so it will convert the data into a standard normal distribution where the mean is 0 and standard deviation is 1, right? So I'm applying this to all these columns so that the data gets standardized. Now you can see that now the transform data is the standardized data, we can say. So this is the x value. X value is independent variable and y is our target variable. So x is already defined here by using this all the 21 columns, and last column is the fatal age, that is our target column, right? Now this is our target column. Okay, this is one. Now next one is we have to split the data into training and testing, and you have to use the cross validation methods also, right? So as usual we have to use the trend test split here, and we are using a 30% data for the testing and 70% data for the training one, right? So you can see how data is distributed in the training and the testing one. Okay, once the data is splitted, then you have to build the models. Now already we have discussed, we are going to build the four models. One is logistic regression, k-means, k-nearest neighbors, and random forest, and gradient boosting machine, right? The four models we are going to build. Out of that, the when you use this one, so this is nothing but we have imported all these algorithms from this scalar library, right? So now you can see that this is from linear model, this is from neighbors, and this is from ensemble technique, right? So these two are the tree based algorithms. Now first we will build the logistic regression. So we are using a logistic regression. Then once this model is once already we have imported this, we are creating a object of it. Then we are fitting the data to the model so that training is happening. So in this phase we are fitting the model, and finally we are predicting the output. So dot predict x test, so it will give the y prediction for the linear regression. We are checking the accuracy of this particular model by using accuracy score, because already we have imported the accuracy score. Y test means y true into y predicted into 100, and we are printing this accuracy. So now you can see that the accuracy of the logistic regression is 89.34%. So it is giving a good accuracy actually, but we have to cross validate this also. So for that I am importing this cross val score and the stratified k fold, and here I am using three folds actually, and you can see that I'm using a cross val score, then estimator here, the x train y train I am using, then CV method is this three folds I am using, then and jobs is 2, scoring is accuracy, and based on that what you will get, so you will get the three folds means the data is divided into three folds and we are getting the accuracy, right? Three accuracies here. You can see that we are getting three accuracies, and cross val score we can take the mean value of these three. So 89.7, right? So you can see that there is a slight increase in the accuracy in the cross valve, but this is not the case actually. So we can check it for the whole data. Okay. Yes. So now the next one is we have to, if you want to improve the accuracy, we have to hyper the tune the some parameters, that is called as the hyperparameter tuning. So now here for the logistic regressions we have selected these parameters, and we are using a grid search CV algorithm to find out the best model with the best hyperparameters. Now you can see that these are the hyperparameters, and I'm running this grid search CV estimator, these parameters CV, verbose, and jobs, scoring is accuracy, and return trend score also. So when you run this, this grid search CV algorithm is ready. Now we have to fit it to the extend and wide range, and finally you will get the model. So now the best model is the logistic regression with C value is 10. Now with this, you can see that C value is 10, and this is the best one, and the best accuracy is 89.9. So earlier it was 89.34. Now the after the hyperparameter tuning it is becomes 89.9. So there is a slight increase in the accuracy. Now you can check the model performance by using a classification report here, y test and y prediction, this one. So we have to check the precision, recall, F1 score, these things also, right? So so these values are slightly there is a some difference here. Okay, so but again it is giving quite good results, right? So this is all about the classification reports where you can check the precision, recall of one scores also along with the accuracy. Then confusion matrix is the matrix where you can check the true positive, true negative, false positive, and false negative here, right? And you can check it on the heat map so that you will get the nice visualization of this misclassified also. So this diagonally is the correctly classified, and rest of all the values are the misclassified actually. Now the next model is the k nearest neighbor, where we have to follow the same steps. First we have to create the object of the model, then we have to fit it, and then you have to check the score of that. Okay, this is the testing source, so 87.8%. Then we have to check the cross validation score by using a cross val score, and for three folds. So you can check the cross val score is 90%. We are taking a minimum mean value of these three accuracies. Okay, and then hyperparameter tuning. So we have selected these parameters for the KNN, and when you fit it with the grid search CV algorithm, so it will find the best parameters with the best model, and the best accuracy is 90.9. So earlier it was the 90, now it's 90.9. Okay, so there is a improvement in the accuracy. So you can check the precision, recall F1 score also. Okay, then the confusion matrix for the KNN, and this is the visualization of the confusion matrix for KNN. The next model is the random forest classifier. You can see that again the same thing we are following here, and you can see that 92% accuracy we are getting, 92.5% accuracy. Then we are checking cross validation score. It is given 93.8 mean value for these three accuracies for three folds. Then hyperparameter tuning, we have selected these parameters and fitted to the grid search CV. So it will find the best model with the best parameters here. You can see the criterion, minimum sample split, minimum sample leaf, n estimator is 100, and finally we are getting the accuracy is 94.5. All right, so this is actually the best um, best accuracy we can say here, right? 90 okay, 90 94 point, okay, around it's 94, right? So you can check the classification report also here, with precision recall F1 score, then confusion matrix for this. Okay. um, Now the last model we are building is the gradient boosting algorithm. It is again the tree-based algorithm in Simber technique. The same things we are using. Again, we are getting a 93.4% accuracy. Then we are checking a cross-val score. It's a 94.6%. Okay, so there is improvement in the cross-val. Then hyperparameter tuning, we are using these parameters for checking for the best model, and when we fit it with the grid search CV algorithm, so it will find the best model with the best parameters, right? And finally we are getting the accuracy which is around 95%. So now as of now it's best accuracy for out of these four models. So you can check there's precision recall in F1 score, and you can see these results are also very good, right? Then you can check the this confusion matrix for guiding boost classifier here. So we know that the best accuracy is for guided boost. So we have to select the model out of that score, because already we know that this model is working fine. Gradient, all models are working fine, but we have to select the best model with good accuracy, good precision, recall, and F1 score. Okay. So here the recall is very important, because in the medical or the healthcare projects, basically we are more emphasize give the more emphasis on the recall, or it is also called as a sensitivity, right? Yes. We have to select the best model. So we are creating a data frame, and here I'm giving the four models, and just like dictionary and scores. Already we know that the score for each and every model. Now we are creating a result data frame here, and you are getting the model and its score. So you can see that the gradient boosting classifier is giving a best accuracy, or the out of these four. So random forest is also giving a good 92.47, logistic regression, and KNN. So KNN is the lowest accuracy model. So here for this particular case use cases, we are selecting a gradient boosting classifier with the best hyperparameters, and then we will deploy the model so that whenever new data comes, we can predict the health of the fetal. Okay, and based on that, the healthcare healthcare people can start the treatment, okay, based on the fetal health. So this is all about the end-to-end project to check or to predict the fetal health. um, if you have any questions or you can edit out, you can just comment, or you can reach out to me on this channel. And if you like this, so you can hit the like button and subscribe this channel. Okay, so this is all about the fetal health prediction project. Thank you.